Alright, hello everyone. My name is Jacob Batiru, Batirsi, back with another math chapter. I originally was supposed to record this on the computer, but I am not able to do that, so as a last resort, I'm just gonna do this on my phone. And I hope you guys enjoy. So this chapter is 5.6 complex numbers. And without any time to spare, let's get it on. Okay, so imaginary numbers. An imaginary number I is defined as a number whose square is -1. So you see, if -1 is underneath the square root, it's instantly an I. And when I is square, it equals to -1. It's pretty self-explanatory. An imaginary number is any number of the form a plus bi, where b doesn't equal to 0. A is a real number, bi is the imaginary number. A and b are real numbers, including 0. Imaginary numbers are real numbers together make up the set of complex numbers. And over here I have a few examples. So let's say, I don't know, square root of -25 plus 7. So you see, we can have a negative underneath the square root. So we usually just take the square -1 away from the 25. Then this instantly becomes an I. You square root the 25, and it turns into 7 plus 5i, since 5 is the square root of 25. And same thing for this one here. There's a -12 underneath the square root, and we can't have that. So we usually just break it down. A -1, a 4, and a 3, since 4 and 3 make 12. The -1 becomes an I, the 4 becomes a 2, and therefore we have 2i square root of 3. Okay, absolute value. Absolute value of a complex number, its distance from the origin on the complex number plane, which is basically like a graph. And you can find this by using the Pythagorean theorem. A square root of a plus bi is equal to a squared, square root, a squared plus b squared, and you square root it. For the example here, see, we have 2 plus 6i. We want to find the absolute value of it. So we use the Pythagorean theorem. 2 to the square root and 6 to squared. 2 squared plus 6 squared, sorry. That comes to 4 and plus 36. We add that together, get a 40 square root. Now I could simplify it, but then we'll just get like a big old decimal. Adding inverses. So basically, you see the plus and minus. All we do is just switch them around. The 3 becomes a positive, and 8i becomes a negative. You see that? You see it? Adding complex numbers. This is pretty self-explanatory. 6 plus 7i plus 5 plus 2i. The 6 will basically, we just have to combine like terms. the 6 going to the 5, the 7i going to the 2i, and we just get an 11 plus 9i. Multiplying them. Oh, and another note, you can also do this with subtracting. You just have to make this here negative. Well, any of these negative will do. Let's see, multiplying complex numbers. Now this one we have to distribute them. We have to do 7 times 3, then 7 times I, then 2i times 3, and 2i times I itself. We get 21 plus 7i plus 6i plus 2 to the I square. And since I squared equals -1, the 2 becomes a negative 2. So all we have is just to combine like terms. 6i plus 7i will equal to 13i, and then you do 21 minus 2, and you'll get a 19 plus 13i. And finding complex solutions. So basically, you just minus 343 both sides. You divide by 7, and it will become a 49, negative 49. You square root them, and you'll get an x plus and minus 7i. And the way you can check that is if you plug in the 7i and negative 7i into the x. And I guess this is it for me. I hope you guys enjoyed this video. Sorry if I stuttered a bunch. Yeah, I really apologize for that. And I hope you guys enjoy this. Okay? Peace.